Hiya! Uh, so in this video, we're going to be talking about skewness, which should be the last topic of this week. So just like we did for the binomial distribution, remember how when we were looking at the normal approximation for it, sometimes it wasn't very good, right? It was kind of skewed a little to the left and right. And we kind of get a similar thing that happens with the central limit theorem. So even though we can approximate our functions with a normal approximation, it's still going to be sometimes skewed. And we're going to look at where this skew factor comes in from and kind of where everything kind of falls into place, or like why things fall into place. So the first thing we're going to look at is, since in the central limit theorem, we're always looking at this kind of formula, right? I guess I should highlight this instead. Since we're looking at this kind of formula, what we're going to do is we're going to look at our star that we had done in our standardization kind of area. And we're going to look at the moments in this case. So the first moment, this we had already kind of done, right? So as a quick reminder, if we have e of ax plus b, this is just a of e of x plus b. So what we end up having is x minus e of x over sd of x. This right-hand side is a constant, so we get e of x minus e of x over sd of x. So we get 0. What happens in the second moment? The second moment is actually fairly similar. So we would just have to square what's inside. So here on the bottom, I can pull out an sd of x squared. And then on the top, what do I have? I have x squared minus 2e x times x plus e of x squared. So this you should kind of notice is just the variance, right? Because we end up getting minus e of x squared and then plus, so we get the variance of x. And this here, so this is variance. This here is just the square root of variance squared. So this is just the variance on the bottom too. So we just get 1. So basically we have a nice distribution in essence, right? And so the question then becomes, we want to know how much we're off by, right? So this is basically saying, okay, we should be in the center, and the variation should be kind of separated. But how do we know if this isn't like this or something? Like, stop giving me all of that. How do we know it's not something like this, right? Something that's skewed a little bit, but not fully. And this is where we define the skewness from. So the skewness is actually coming from the third moment. So we just do this a third time. And at this point, you should kind of see what we would have to do. We would just have to do the cube here. So x minus e to the x cubed divided by the standard deviation of x 3 times. And this is how we define the skewness. And that's basically where that formula from before was coming from. We just defined it in this way. And for independent variables, so if I were to take in the sum, what we actually just end up getting is we just take the skew of any one of them and divide by square root of n. And that's how we would get the skewness. And so we're not going to try to show where this formula comes from. Like, don't worry about it too much. But yeah, so it's definitely you can definitely calculate it. It's not too difficult. But just note, like, we're not going to try to show where this comes from. You can solve it. I actually show you how to solve it. Basically, the two things you want to do is you want to show that this is equal to that these two are equal to one another, and that this is equal to that. And then the ends kind of cancel and you end up getting this. Here, Oh, this is the wrong form file. Anyway, there's the right file online. I don't know why this downloaded the wrong file. Um, oh yeah, your version will be different. So here, what is missing? X1 plus, oh, the thing that's missing here, x1 squared. This is missing a cubed here. And then here we're missing a little bit more. Here this final term should be plus 3 of e of x squared to e of x squared. I thought I had fixed this, but I guess I did not use the right formula. Use right file. Anyway, so we end up getting that. And so here you can kind of see how to do it. Don't look at this if you don't want to. This is just looking at when n is equal to 2. The actual formulas themselves are significantly more complicated for just an arbitrary n. So we're definitely not going over that. But this, I wanted to give an idea of where the skewness idea is coming from. Again, where, like, as you saw, I don't give really an example. And that's because we're probably not going to be using this that often. It's good to know the formula and you kind of see where this original idea of skewness is coming from. So if you're ever required to do this for a job, you know how to do this. Like, you just can go back and look at where this works and how this is kind of coming from. But that's basically where we're going to end. We're going to end it on this idea that skewness is just coming from the third moment. So if you want an even more accurate thing, well, you're just going to look at the fourth, the fifth, the sixth, the seventh moments, and each moment is going to make you a little bit more accurate. And that's basically the idea here. Each moment is going to make things more and more accurate. And so, yeah. So that's it for this week. I will see you next week for more fun topics in math and probability in particular. So I will see you then. Hope you're enjoying reading week, or hope you have enjoyed reading week. Bye.